Hello everyone. I'm going to discuss today the difference between tautology and a contradiction. These are two special propositional forms. Uh, the tautology is defined to be a propositional form that is always true, regardless of the truth values we assign to its components, while a contradiction is a propositional form that is always false, regardless of the truth values we assign to its components. And to illustrate that, let's consider the following examples. And let's start with a very simple propositional form given by P or negation of P. So to determine whether this is a tautology or a propositional form, the easiest way of determining that is by constructing a truth table for this propositional form. If you remember, we discussed previously the truth table. So to construct a truth table for this, in this column we indicate the P. Since there is only one propositional variable, then that means that there are only two possible truth values for that propositional variable, and that is true or false. In the propositional form, we have a negation of P. Aside from P, we also have negation of P, so we determine the truth value of that. Of course, the effect of the negation on P, the truth value will become false whenever P is true and become true whenever P is false. And then for P or negation of P, okay, we recall of course that under or, okay, under or if you have P or Q, if you remember, the truth value of P or Q is this is true when both P and Q are true. This is still true, no? If at least one of them is true. But if both of them are false, then we say that P or Q is false. Okay, so take note of this. Recall this one. So what is now the truth value of P or not P? You have true or false. That gives you true, right? Because under or, you have true if at least one of them is true. This one also is true, okay? Now, take note of this particular column. This shows the truth table for P or not P. And we have all true for every possible truth values for its component. So we conclude that P or negation of P is a tautology. Okay. For our second example, let's consider say negation of Q and Q. Now, is this a tautology or a contradiction? Let's again construct the truth table. We have only one propositional variable, and that is Q, so that means that in your truth table, you only have two possible truth values for Q, no? That's either true or false. Then the propositional form consists not only of Q but also negation of Q, so we indicate here the negation of Q. Again, this is false because Q is true, and this is true because Q is false. And for the truth value of negation of Q and Q. Okay, again, we recall the truth table for P and Q. We say that there's only one instance where P and Q is true, and that is when both P and Q are true. But when one of them, at least one of them, is false, then your P and Q is false. Following that idea, here we have true, false. So under and, that's of course false, and this is false. Okay, so you see that your truth table for negation of Q and Q reveals that for every possible truth values for its components, you have all false. So our conclusion is negation of Q and Q is a contradiction. Okay. Now let's consider a more challenging one. This time we're going to determine whether, it should be P and negation of Q or negation of P or Q. So question is this a tautology or a contradiction, or neither? Let's find out by constructing again the truth table. Now, maybe in this particular example, this is example number 3. In this particular example, I'm going to illustrate the alternative method of constructing the truth table. You will find this I don't know, maybe easier to use, but the advantage of this method over the usual construction of truth table is that you actually save some space, okay, when using this method. You can try this. So let's try to construct this. Our objective, of course, is to determine whether this is a tautology or a contradiction. But at the same time, I'm going to illustrate how to construct the truth table using that alternative method. How many propositional variables are there? There are actually P and Q. So there are 2 propositional variables. That means that we have how many combinations for the truth values of P and Q? Let's see. If you have 2 propositional variables, the number of possible combinations actually is determined by 2 to the n, where n is the number of propositional variables. So that means that we expect here to have 2 squared, which is 4. And these are true, 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 false, false, true, and false, false. Now, instead of finding the truth value for negation of Q, negation of P, P and negation of Q, negation of P or Q, let us just indicate the propositional form here. Okay, and then we will determine the truth value of this now for every possible combinations of the truth value of P and Q. Let's start first with finding the truth value of P and negation of Q. Then after that, we find the value of negation of P or Q, and then after that, for our last and final column, we're going to determine the truth value of these 2 under or. Okay, but before we can find the truth value of this, of course, we have the truth value for P, and we need to find for the truth value of negation of Q. So you can indicate that actually in this column here. You can just copy the P, although you may choose not to copy anymore, but just to avoid confusion, you can just copy that. Okay. Negation of Q, your Q is here, so negation of Q means this is false, this is true, this is false, and this is true. And to find for the truth value of P and negation of Q, we consider these truth values, no, of P and negation of Q respectively. So under and, remember this, okay? Under and, there's only one instance where P and negation of Q is true, and that is when both of them are true. So that means that this is false, this one is true, this is false, and this is false. Let's mark this one. Let's consider this as our column number 1. Okay. Now we find the truth value of this. Again, P here is true, true, false, false. So that means the negation of P is false, false, true, and true. While Q is, let's just copy that. You have true, false, true, false. Okay, then under or, negation of P or Q is, okay, remember again, there is only one instance that P or Q is false, and that is when both of them are false. So that means this is false, while the rest are true. Okay, and let's mark this. This is our column number 2. Now for our final column, which will represent as the truth table for our propositional form, we will relate column number 1 and column number 2, okay, for our final column. And the connective here is or. Again, according to the basic truth table, no, of P or Q, there is only one instance that this is false. But if you notice, at least there is one component that is true. So that means that this is true, this one is true, false, true, so this is true, and this is true. So what do you say about our propositional form? Is this a tautology or a contradiction? So obviously this is a tautology, because our truth table shows that the propositional form is true for every possible truth values of its component. Okay, for our next video, we're going to discuss another idea, and that is about equivalent statements. So I hope you have learned something. I'll see you again in our next video. God bless.